In this video, we'll explore some of what you can do with the spine-godot runtime by checking out the sample scenes that come with it. This runtime is implemented as a custom C++ engine module and requires a custom build of the Godot editor as well as the Godot export templates. On the SpineGodot runtime documentation page, you can download pre-built editor and export template binaries. Download the Godot editor for your operating system as well as the Godot export templates. For Windows and Linux, unpack the zip file and place the extracted executable file anywhere you like. For macOS, place the godot.app into your applications folder. To install the export templates, create or open a Godot project, then choose Manage Export Templates via Editor. Click Install from File and select the .tpc file you downloaded. To inspect the samples, clone the Spine Runtime Git repository or download the latest version as a zip and unpack it. There are two sample projects, one for Godot 3.x and one for 4.0. In this video, we're going to open the former. Open the Godot editor and click Import, then select project.godot in the example folder via the Browse button. Let's start by opening the first sample scene. This scene demonstrates how to use a SpineSprite node to display and animate a spine skeleton. When playing this scene, SpineBoy will play the walk animation. The SpineSprite node displays the skeleton data and atlas stored in a SpineSkeletonDataResource. SpineBoy's SpineSkeletonDataResource can be found under the SpineBoy folder in the Assets folder. A SpineSkeletonDataResource loads a skeleton file and an atlas file. This allows sharing that data efficiently among multiple SpineSprites. Instead of each SpineSprite needing to load all the data, sharing the SpineSkeletonDataResource means the data is only loaded and kept in memory once. Let's take a look at the process of creating SpineSkeletonDataResource. Open your project in Spine and export the skeleton in JSON or binary format. You should prefer binary exports over JSON exports as they're smaller in size and faster to load. If you must use JSON, make sure the file extension is spine-json instead of JSON. Create a new output folder for convenience in later steps. Check the Pack checkbox to pack the texture atlas and then export. Drag the output folder into Godot to copy and import it. The asset importer will create a spine skeleton file resource for the skel or spine JSON skeleton file, a spine atlas asset resource for the atlas file, and a Godot texture resource for each PNG file of the atlas. To create a SpineSkeletonDataResource with these, right-click on the folder and select New Resource. In the dialog, select SpineSkeletonDataResource, click Create, give the resource a name, and click Save. Double-click the newly created resource so it shows up in the inspector doc, and then assign the previously imported atlas resource and skeleton file resource for your skeleton. The skeleton data resource also stores default mix, used for mixing between animations. You can also specify the mix duration between specific animations by pressing the Add Mix button. For example, if you want the mix duration to be 0.2 seconds when mixing from idle to run, you can set it like this. Once imported, you can update the skeleton by simply overwriting the modified file. Let's display the newly imported skeleton data in the viewport. Click the plus button in the scene dock and select SpineSprite. Select the added node in the scene tree and assign a skeleton data resource to it. Now your skeleton is displayed in the viewport. The SpineSprite node inherits from node 2D, so you can move, rotate, and scale by editing the transform of the node 2D or using each mode. You can change properties in the preview section to see skins and animations in the editor viewport. If you do not set any skin or animation via your script, the skin or animation set in the inspector will be used when playing the scene. Reset the scene to its original state and let's look at how to animate a SpineSprite. Animating a SpineSprite is done in code via GD script or any other scripting language supported by Godot. Select the script attached to the SpineBoy node. In this script, the walk animation is set to animation state in the ready function. The SpineSprite exposes a spine animation state via getAnimationState. It has three parameters. The first is the name of the animation, the second specifies whether to loop the animation, and the last parameter specifies the animation track the animation should be played back on. Animation state has the concepts of tracks, where animations with higher track numbers are applied on top of lower tracks. For example, if you copy the code in line 4 to line 5 and then change the animation name to aim and the track index to 1, the aim animation will be played on track 1, while the walk animation is played on track 0 simultaneously. Play the scene to see the result. If you set the loop to false for the aim animation, the result will be the same because the last pose of the animation will be kept until another animation is applied to the track. Queuing animations is also done through the animation state method addAnimation. For example, if you like the run animation to start playing 2 seconds after the walk animation, it can be written like this. addAnimation takes the same three parameters that setAnimation takes, plus a new second parameter called delay. This is the number of seconds after which the animation will replace the previous animation playing on the track. When playing the scene, you can see that the walk animation plays in a loop for 2 seconds and then the run animation replaces it. To reset the skeleton back to the setup pose, you can use the setEmptyAnimation or addEmptyAnimation methods. For example, if you would like to reset the aiming pose when the run animation starts playing, it can be written like this. The first parameter to addEmptyAnimation specifies the track. The second parameter specifies the mix duration in seconds used to mix out the previous animation and mix in the empty animation. The third parameter is the delay in seconds after which the empty animation should replace the previous animation on the track via mixing. Let's see the result. The aim animation was mixed out smoothly. The list of animation state methods can be found in the Spine Animation State documentation, which can be viewed by holding the Control key or Command on macOS and clicking on the method name. When setting or adding an animation to an animation state track, a SpineTrackEntry is returned, which allows further modification of the properties for this specific animation playback. For example, you can set the track entry to reverse the animation playback. Let's see the result. The walk animation is played backwards, but the run animation is played as normal. Track entry has many methods to customize playback, so please refer to the SpineTrackEntry reference for more information. The second sample scene demonstrates how to listen for animation state changes on a SpineSprite using signals. Let's take a look at the script attached to Node 2D. Here you can see the sample code to connect to each of the 6 exposed signals. When playing the scene, SpineBoy will play jump, walk, and run animations, and you can see messages that the signals were issued during the animations in the output doc. Let's inspect the printed messages. First, animation started is emitted when the animation has become the current animation. Then, animation interrupted is emitted when another animation has replaced this animation as the current animation. This animation may still be applied for a while as it is mixed out. Animation completed is emitted every time the animation completes a loop. Animation ended is emitted when the animation has finished any mixing out and will not be applied again. Animation disposed is emitted when the animation's track entry is disposed. No references to the track entry should be kept after the disposed event. In this example, jump is set not to loop, so when it ended, the animation completed, ended, and disposed signals were emitted. Walk is mixed in 0.1 seconds before jump ends according to the default mix value defined in SpineBoy's skeleton data resource. So the animation started of the walk animation was emitted before the animation completed of the jump animation, and animation interrupted was emitted since a new animation was set. The run animation will be played indefinitely and will not be replaced or interrupted by any other animation. So only animation completed will be emitted at the end of each loop. Animation started is not emitted when the loop starts. Animation event is emitted when a user-defined event happened. This can be defined when creating an animation in the Spine editor. In this example script, if the event name is footstep, the play method of the audio stream player node is called to play the footstep sound. In addition to animation state events, a SpineSprite also exposes signals for its higher level lifecycle. If you're interested in them, please refer to the documentation. This scene demonstrates how to create a custom skin composed from other skins for mix and match avatar creation scenarios. Nothing is shown in the viewport because the skeleton has no default skin set, but when playing the scene, you can see a dancing character. Let's see how to combine multiple skins through the example script attached to mix and match. First, fetch the spine skeleton data from the spine skeleton the SpineSprite manages. This is used to call findSkin to look up skins by name. Next, create a new custom skin and add all the skins you want to combine to the custom skin by calling addSkin. Finally, set the custom skin on the skeleton by calling setSkin. Note that if you set another skin later, you may want to call setSlots to setup pose after setting the skin. If you do not call it, the previous skin may remain partially in place and not look how you like. This example script also demonstrates the use of the getAttachments method, a method of the SpineSkin class. It returns all attachments in the skin. This example script uses it to print all slot indices and attachment names in the custom skin. The slot index and attachment name can be used to manipulate attachments in specific slots. For example, you can remove a specific attachment by passing its slot index and name to the removeAttachment method. To get the index of a slot, find the slot name via findSlot, then access its index, which is stored in its data via getData.getIndex. To learn more about the SpineSkin class, please see the class reference. This scene demonstrates how to play different animations in reaction to input events. When playing the scene, press the left arrow key and SpineBoy will start running to the left. Press the right arrow key and SpineBoy will start running to the right, and release the key to return to idle. Let's look at the script attached to the SpineSprite node of SpineBoy. The idle animation is set in the ready function. In the process function, the run animation is set when the left and right keys are pressed respectively. To flip the skeleton, the SpineSkeleton.setScaleX method is used. Unlike setting the scale of the node 2D transform to a negative value, only the skeleton is flipped. For example, if you put a sprite node on a SpineSprite child, the sprite will not be flipped. This scene demonstrates how to make a bone in a SpineSprite skeleton follow the mouse or touch events. When playing the scene, the crosshair moves according to the mouse position and the angle of the upper body changes so that SpineBoy aims at the crosshair. Looking at the scene tree, this SpineBoy has a child node named Crosshair Bone. This is a spine bone node that can either follow a skeleton's bone or drive its transform. Bone mode specifies whether the node should follow a bone in the SpineSprite or if it should drive it. The drive mode allows you to set the transform of a bone based on the node. The follow mode allows you to attach a node to follow a bone in a skeleton. To create a spine bone node, right-click the SpineSprite you want to attach the node to, then select Add Child Node and choose Spine Bone Node from the list of available node types. Let's take a look at the script attached to Node 2D. In the Ready function, the walk animation is set to track 0 and the aim animation to track 1. The aim animation uses IK constraints and a transform constraint to change the angle of SpineBoy's upper body when the crosshair bone moves. Then within the process function, the global position of the crosshair bone, which is the spine bone node, is adjusted to the mouse position. Global position is a property of Node 2D. This means that Spine Bone Node can be used to move a specific bone with Node 2D properties. In fact, you can move the bone position in the viewport as well. If you comment out the entire process function and change the position of the crosshair bone in the viewport, then play the scene again, you can see SpineBoy will aim according to the position of the crosshair bone in the viewport. Scale and rotation can be changed as well. The next scene demonstrates how to use a spine bone node on a SpineSprite to let a child node follow a bone in the skeleton. When playing the scene, SpineBoy will play the walk animation and the Godot icon will follow the tip of SpineBoy's gun. Looking at the scene tree, there is a spine bone node called gun tip bone, which has a sprite node as a child node. When bone mode is set to follow, the node follows the bone specified in bone name. Note the child node will not be properly inserted into the SpineSprite draw order. If you look carefully, you can see that the sprite is drawn in front of SpineBoy, even though the gun is hidden behind the legs. If you want to insert arbitrary nodes into the drawing order of the parts making up a SpineSprite, you can use the spine slot node, which we will look at later. Also note that a spine bone node must always be a direct child of a SpineSprite. Otherwise, it will be unable to locate the bone it should follow or drive. This scene demonstrates how to use a spine slot node to insert a child node into the SpineSprite's draw order. When playing the scene, you can see the raptor follows SpineBoy's gun, the Godot icon follows SpineBoy's eye, and the little SpineBoy follows SpineBoy's front fist. Looking at the scene tree, you can find 3 spine slot nodes: gun slot, eye slot, and front fist slot, which are children of the SpineBoy SpineSprite node. Each spine slot node has a child node and it is inserted in the draw order before the slot that is set in the slot name property. This allows you to use particle systems, custom sprites, or even other SpineSprite nodes within the draw order of the skeleton. While these spine slot nodes transform cannot be modified, its children can be freely adjusted while maintaining the slot's drawing order. To create a spine slot node, right-click the SpineSprite you want to attach the node to. Select Add Child Node, then select Spine Slot Node from the list of available node types. Like Spine Bone Node, Spine Slot Node must always be a direct child of a SpineSprite, otherwise it will be unable to locate the slot it is assigned to. You can also use Spine Slot Node to override the materials of a particular slot. We'll look at this later. This scene demonstrates how to use a Spine Animation Track node to create cutscenes using Godot's Animation Player user interface. When playing the scene, SpineBoy walks from left to right, Raptor appears from the right and roars, then SpineBoy falls backwards. A Spine Animation Track node lets you animate a SpineSprite via Godot's powerful animation editor. It can be easier to create cutscenes using Godot's animation editor rather than writing code. However, please note, Spine Animation Track must be considered experimental due to Godot's animation engine not exposing all the necessary functionality to third-party plugins. To create a Spine Animation Track, right-click the SpineSprite you want to attach the node to, select Add Child Node, then select Spine Animation Track from the list of available node types. When creating a Spine Animation Track, an Animation Player node is created and attached as a child. A SpineSprite is then animated by keying both the Spine Animation Track and its child animation player. You set the animation to be played by keying the child animation player. Let's go through the process of creating an animation using Spine Animation Track. First, create an animation for the animation player node. Give it the name Test. Set the animation length to 5. Select the animation playback track via the Add Track button in the upper left corner. Select the child animation player in the list. Right-click on the added track and select Insert Key. Select the inserted key and set the animation property to jump in the inspector dock. Select the script attached to Node 2D and change the parameter in the player.play method to test. Then play the scene to see the result. SpineBoy jumps once, but stops in the last pose after landing. If you want to reset to the setup pose after the animation has finished playing, you must set an empty animation just as you did when setting the animation to animation state in the first sample. To add an empty animation, add a key by right-clicking as before and set the animation property to empty. Play the scene again, then you will see SpineBoy return to the setup pose, but you will also find his pose is suddenly changed after the jump animation. This is because the mix duration of the parent spine animation track is set to -1. You can achieve a smooth mix by setting a positive value here, but it will be applied to all animations of the child animation player. If you want to change track settings for each animation, you can add property track via add track. Select the spine animation track node in the list. Next, you'll be asked which property to add. Select mix duration. Right-click on the added track and add a key via insert key. Select the added key and change the value property to 0.3 in the inspector dock. The easing curve has no effect on the transition as long as the value is applied fully before the mix starts, so here we will leave it as default. Play the scene again, and now you can see the landing is smoothly reset to the setup pose. Note that mixing cannot be previewed in the editor viewport. You will need to play the scene to see mixing. Animations that have the suffix _looped in their name will be looped. These animations are automatically added when the spine animation track node is created. The loop continues until the next key on the same track. You can also add higher tracks to play multiple animations simultaneously. This scene demonstrates how to apply custom materials to an entire spine sprite as well as individual slots via a spine slot node. If you select the SpineSprite node and check the properties, you can find that a custom material is set to the normal material property. The shader for this custom material simply sets the red color of the texture to 0, which causes most of SpineBoy to appear in a blue-greenish color. However, the gun slot has a yellowish color because it is overwritten with another custom material via spine slot node. The shader of the custom material sets the blue color to 0, so only red and green color remain and look yellowish. This scene demonstrates how to use normal maps in combination with a SpineSprite to support Godot's 2D lighting system. For lighting effects, you must provide normal maps for your texture atlas. Each PNG making up a texture atlas page must have a corresponding PNG normal map image next to it in the file hierarchy. The normal map image files must have a common prefix. The default prefix is n_. The raptor skeleton has a normal map image named n_raptor.png next to raptor.png. Upon importing a texture atlas, spine-godot will try to locate and load normal map images for each texture atlas page image. You can define your own normal map prefix in the import doc when you select the atlas file in the file system doc. As mentioned earlier, the API reference is available in the Godot editor, so if you have any questions about the APIs, just hold the Control key or Command on macOS and click on the method name. You can also search for a script by clicking the Search Help button in the upper right corner when the script workspace is selected. You can easily find references to various classes by typing spine in the input field at the top. You can also see the details of each node by clicking on the button next to its name. Besides the examples and documentation, you will find even more information on the Spine forum where you can post your questions if anything still remains unclear. I hope this video has been helpful, and thank you for watching.